I'm Anil Kumar. In this video, I'll discuss how to find area of triangle when there is a possibility of having two triangles. Here are two examples. Find area of triangle for A, triangle DEF, where D equals to 17, E equals to 18, and angle D equals to 63 degrees. Another triangle is KRS, where side lengths K and R are given as 3.2 and 2.9. Angle R is 2.1 degrees. Let me first discuss how to solve such problems. Then you can copy solve questions and thereafter look into my solutions. So let's first make this triangle DEF. So let's say that this is the angle given to us, angle D, which is 63 degrees. Now in this particular triangle, we are given side length D, which is opposite to this, as 17. So let me just join this like this, and we are given this side as 17. 18, let me write here, so the vertex E will be right there. So this E is 18. We need to find area of this triangle. Let me call this as F now. Now as you can see, if I use one of these sides, then I'm using one of these sides as a base also, correct? So let us say that EF is my base. In that case, altitude will be kind of like this, correct? That becomes the altitude. And area of triangle will be of triangle DEF will be half base, which is EF, times height, which is, let me call this point as P, as dP. Now dP could be written in terms of dF, which is 18, so it will be half EF times sine of this angle F. Let me write D, whatever, ED, sine of angle F. Do you see that? This angle. So since this side is opposite angle F. So that is the case. Now you have also learned about ambiguous cases. With this condition, we could also find what is, we already know that this side 17 is less than 18, right? So we know that 17 is less than 18, so we could have ambiguous case. That means two triangles are possible. So we need to find what is 18 sine 63. And if this is less than 17, then we have two triangles, correct? So the other triangle will be kind of like this. Let me call this E dash. So that case, we have to also find the area of the second triangle. So need to find area of second triangle, because there are two possible triangles, that is triangle DE dash F. Do you get the idea, right? So that is the strategy which is going to be applied while solving these questions, correct? So let's take them one by one. So the first one here is DEF, which we were discussing. So let me sketch the triangle again. Let me sketch it here now. DEF, and sides given to us are 17, 18, angle D is 63 degrees. Now we're looking for this to be the altitude, correct? And therefore the area of this triangle should be DEF should be equal to half of 17 times 18 times sine of angle F. So we need to find angle F, correct? Now, before that, since we are given one combination of 63 and 17, we need to find angle E, and then we can find angle F, right? So let us first consider, do we have ambiguous case or not? So let's figure out what is 18 sine of 63 degrees. 18 sine of 63 degrees is equal to 16.038, and definitely this is less than 17, right? So that means we have two possible triangles, correct? So the other triangle will have the same length as 17, however, that will be kind of like this. Do you see that? So I'm calling this point as E dash. So we have to work for two triangles, remember this. Okay, let's first solve this big triangle. So in the big triangle, we can always apply sine law. So we can say sine of angle E over the side opposite 18 equals to sine of angle D, which is 63 degrees over 17. So sine of E equals to 18 times sine 63 over 17. So let's calculate this value. 18 times sine 63 divided by 17 equals to, so angle E, so this is equals to 0.9434. Let's take 4 decimal places, right? So angle E is equals to sine inverse of 0.9434. So we'll do sine inverse of this, shift sine inverse of our answer is equal to 70.63. Let's write 70.63 degrees. We'll take two decimal places, correct? So what we find here is that this particular angle is 70.63. Now what is angle F in that case? Let's figure that out, right? So angle DFE will be equals to 180 degrees minus 63 minus 70.63, right? So that is 180 minus 63 minus 70.63 equals to, in decimals, 46.37. Right? So 46.637 degrees is the angle F. Now we can always use the formula, and we say area of the triangle DEF is equals to half of 17 times 18 times sine of this angle, which is 46.37 degrees, right? So we get 17 times 18 times sine of 46.37 equals to, divided by 2, 110.74, right? Unit square. So let's say unit square. So that becomes the area of bigger triangle, correct? Now we have to find area of the smaller triangle also. That's very important to understand. So the smaller triangle is kind of like this. I'm just making a figure kind of 18. This side is still 17. Here we have D, and this is E dash, correct? Now what is this angle? Now, since this is isosceles triangle, this angle is also 17.6. So that angle should be 70.6, let's write 63, minus 63, right? So this angle will be So now angle DF, this is okay, that E is for this is F. So angle DFE dash will be equal to 70.63 take away 63 degrees, correct? So that is 70.63 take away 63, and in degrees it becomes 7.63 degrees, correct? So for the smaller triangle, area of triangle DFE dash, it will be half of 17 times 18 times sine of 7.63 degrees, correct? So let's calculate this also. So we get 17 times 18 times sine of 7.63 divided by 2 equals to, I'll calculate it again, 17 times 18 times sine of 7.63, and then we'll divide this by 2, half of this, right? So we get this as 20.31 units square. Correct? So we have two answers here. Since there were two possible triangles, it's an ambiguous case. So the answers are that the area, if I round to whole numbers, it becomes 111 units square or 20 units square, correct? So these are the two cases. So I hope the concept is very clear. We'll take up the next example also. Now here is a test question for you on area of triangle. You understand all the concepts. Now find the area of triangle KRS, where K is given to us as 3.2, R is 2.9, and angle R is 21 degrees. You can pause the video, answer the question, and then look into my suggestions. So let us first sketch the triangle KRS. Since the angle R is given to us, I prefer to take angle R at this vertex. So I'll name this as R. K, I'll name this as K, right? So opposite K is 3.2 and opposite R, it is 2.9. So I'll write 2.9 here, joining these two. Okay. Now, it is possible that we can have two triangles. So first, let us check for that, right? This is S. So to check for that, what should we do? Angle R is 21 degrees. So what we will do here is that we'll find what is 3.2 sine of angle R, which is 21 degrees. 3.2 sine of 21 degrees is equal to 1.146. Clearly, 2.9 is greater than 1.146 and 2.9 is less than 3.2. So we have two triangles, right? So that means we have two triangles. So there could be another triangle like this, which is also equals to 2.9. Do you get an idea? So I'll call this as K dash. So remember, we have to now figure out area of two triangles, not just one. So we are looking at area of triangle KRS and also area of triangle K dash RS. If you don't do that, you miss half the questions. Okay, now let's do it. So let's find the angle K first using sine law. So we'll use sine law to find angle K. Sine of K over 3.2 is equal to sine of 21 over 2.9. So sine K is equals to 3.2 times sine of 21 over 2.9, which is 3.2 times sine of 21 divided by 2.9 equals to, in decimals, 2.9. Well, there seems to be something wrong. Let's redo it. 3.2 times sine of 21 equals to, and we divide by 2.9 equals to, yeah, that's more likely, 3954. So angle K is equals to sine inverse of 0.3954. So we'll do shift sine inverse of our answer, and that is equals to 23.29. 23.29 degrees, which is like 23.3 degrees, correct? Okay, so we get this angle as, let me write this as 23.3 degrees. Okay, so we're rounding. So we'll round this to 23.3 degrees. Now, if this is 23.3 degrees, then what is angle S? Obviously, if this is 23.3, we know what is angle R K dash S equals to, which will be 180 minus this. Is it okay? 180 minus 23.3 degrees. Let's write this also. So 180 minus 23.3 gives us 156.7 degrees. So that is for the next triangle. Anyway, let's find the bigger angle first. So the angle RSK will be equals to 180 degrees, take away 21 degrees, take away 23.3 degrees. That gives us 180, take away 21, take away 23.3 in decimals, 135.7 degrees, right? Now the area of triangle KRS is half product of these two sides, which is 3.2 times 2.9 times sine of angle S, which is sine of 135.7 degrees. So let's calculate this. So it is, let me multiply these two, 3.2 times 2.9 times sine of the angle, which is 135.7, sine of 135.7 equals to, and we'll divide this by 2, 3.24 unit square. Correct? So that becomes the area of bigger triangle. Do you see that? Now we have to find area of smaller triangle. Now what is that angle? So clearly you could also do it like this. These two angles are 23.3. So the smaller angle is how much? Let me redraw this triangle here. Let's redraw it, right? So in this triangle, we know this angle is 21, and this will be, because here we have 23.3, so it is 23.3 minus 21, correct? So minus 21, that is 2.3, so it is just 2.3, correct? You could do like this, or 180 minus. Is it okay? Since external angle is, this angle is external angle, correct, which is 23.3. So if we add these two, we should get external angle. So we are using that. Is it okay? So what we know from here is that the angle RSK dash is equals to 2.3, and therefore area of the smaller triangle RSK dash is half of product of these two sides, because this is also 2.9, both are same, 2.9 times sine of the angle, which is 2.3 degrees. So let's calculate this. 3.2 times 2.9 times sine of 2.3 equals to, divide by 2 equals to 0.186. Okay. So if you are rounding to whole numbers, if I round to, one decimal place, it'll become 0.2 units square, and that will become 3.2 units square. Is it okay? So our answers are rounded to one decimal place will be 3.2 units square and 0.2 units square. Since in this particular case we have two possible triangles. So remember, if you are given a situation where angle side side is given to you, in that case we could have two possible triangles. So check for two possible triangles. So here we found B sine A, right, to check. And if B sine A is less than A, and if A is less than B, then we have two triangles, correct? Once you know that, then you have to find area of both the triangles. That's the concept. I hope this helps you to understand how to find area in such cases. Feel free to write and share your comments. If you like and subscribe, that's going to help me also. Thank you and all the best.